Okay, your phone should not be out at this time. Okay, because then what kills me is when you ask me a question, but you were not paying attention when I was originally explaining it. It kills me inside. Okay, so sketch the inverse of the function that represents the graphs below. This is our original function. I'm going to label that just so that we know. There is this line that we talked about yesterday. If you have a highlighter, I would recommend highlighting it so that you understand what it is. Does anyone remember what this dotted line represented from yesterday? Y equals x. Now, when you're talking about a function and its inverse, it will always be symmetric about the line y equals x. So, with that said, you can kind of predict where your arrow should go. If I were to grab this arrow and flip it over the line, I know it's going to somewhere go in this direction. If I were to take this arrow and grab it and flip it over the line, I know it's going to go somewhere. So kind of a good way for you to check your answers is to look at that line y equals x. But let's actually make it a little accurate. Our original function f of x, give me a point. Negative 1, 3. What else?
0, 0.
And?
1, negative 3.
Beautiful. So what do we do that we learned yesterday if we want to find the inverse of our function with those points that we were given? Yeah, I just start switching all of them. They interchange. The domain and the range changes here. So I have 3, negative 1. 0, 0 remains the same because it's the same number. And what's my last one? Beautiful. Please plot those 3 points. Oop. I messed that up. Okay. And I like to make sure that I label it just so that I remember that that's the inverse. Okay, that's simple. That's all you have to do. And kind of what we talked about earlier validates what we said. If I grab the arrow and I were to flip it over that line y equals x, it makes sense. Always check your answers. Just being able to understand math really, really could be a huge benefit for you when you're on something like the SAT where you'd be able to recognize that. Okay, let's do this next one. We're going to do a few points here. There's a lot going on. Here's my original one. Let's start doing some points. What's this first one here? Negative 2, 4. What else we got?
Negative 1, 1.
All right. Then we got 0, 0. Then we got what?
1, negative 1.
Beautiful. And the last one?
2, negative 4.
Good. I want you to take a second. I want you to write out all the inverse points now. So the inverse. Is it 5? 1, 2, 3, 4, 5. It is 5. Sorry, I don't have my key by me to check it. Sorry, that's supposed to be 5, so please fix that. So please take a second and write out those inverse points. Remember, all you're doing is you're switching the x's and you're switching all the y's. And then go ahead and plot them as well. You might want to wait to actually draw it out, but you can plot them. Hopefully you got those in pink. Go ahead and check your answers when you're done. Wait a second. Make sure you got it all down. Yeah, I think so. I'd have to look at that. I can look at that too during plan. Okay, so I'm gonna highlight this line. I'm gonna repeat myself a million times until it's stuck in your head. What is this line? Yeah, and that means it's symmetric about y equals x. If I were to fold it on that line, it would be symmetrical. So that kind of helps us, and it validates here in our plotting our points, but we should be able to say this arrow here is going to flip to here. You don't have to draw that out, but I wanted to show you. So it's going to be something like this, something like this. And I'm going to label it so that I remember that it's the inverse. You flip the page when you're ready to go. What'd you say? I know graphing can be tough sometimes.
You'll like this.
Yes. So, now let's talk about if a graph represents a function. So when we learned this, I'm not sure when you learned it, maybe in Math 1, 8th grade, not sure. Does a graph represent a function? Was there a way for us to figure out if a graph represent a function? What'd you say? There was probably one. It had something to do with a line. Does anyone remember how I would determine if something is a function based off a line? Well, y equals x is a symmetric, so I know why you are saying that. Okay, I kind of know what you're saying, cutting it down sideways, but not necessarily.
Sideways would be tough.
Yeah, are we doing horizontal or vertical? Soon, to be. But if you wanted to determine if something is a function, if a graph is a function, remember we did the vertical line test way back when, where if I were to draw a line up and down, I'd be able to say, does it cross more than once or does it intersect more than once? And if it does, only do it once, then it is a function. So yes, we can determine it. And if it passes the vertical line test, vertical line test, that's from way back when. So if you were ever asked, is this graph a function? And you're like, I have no idea. Okay, remember a function means that you can only have one input value for your function. So here, if I were to draw a line like this, you don't have to draw it in. It only intersects one time. I'm good. If it intersects twice, it would not be. Something just to kind of remember from way back. So is there a way then we can determine if an inverse is a function? So if our original function was vertical, remember what inverse is. It's the opposite. What would be the way to test the inverse? Horizontal. Very good. So a horizontal line test. So again, we're just trying to show you a way that if you were to just figure out a way, there's a way to figure out if the inverse is even going to be a function. Okay, so let's talk about that. The inverse, for example, here, if I go like this is a horizontal line. You could even draw that in if you really want to. Here and here, how many times does it intersect?
2.
So is it a function? No. So the inverse is not a function because it does not pass the I almost said vertical, horizontal line test. I'll abbreviate it. Okay, so kind of just a way for you to visually see if the inverse is a function or not. Okay. So now let's actually graph it. Well, that's what we did in the first page, so we were pretty good at that. Now, some of you at some point might be like, why am I writing all these points out? That's okay, but for the notes, we're always going to do that just so that you can look back at them. Okay, some of you might be able to say, okay, this is going to be this point. All I have to do is switch it. That's okay, but for the sake of notes, we're actually going to write it out. So our original here,
So got those original 5 points that are on there.
go ahead, yes. Oh my God, my brain. What Ms. Truesdale said, please figure out those 5 points that are on there that we graphed for you already. List them out.
Sometimes we like breeze through this too and you forget negatives and stuff. That's going to throw you off. So be careful when you're writing out those points.
When you are done, check your answers. They're in purple. Give me a second. Yes. Now, what do we do to all of the points of our original graph if we want the inverse graph? We flip them. Okay, so I get 5, -4. I get 0, -2. Then 2, 0. Then, and good. So these are all of my inverse ones. So go ahead and plot those points, please, on your graph. Take a minute. And if you need help, please feel free to ask Ms. Truesdale or myself, because we'd be more than happy to help you right now. Because we want to make sure that you're understanding the basics.
Go ahead, connect them. You have all your points. It'll look kind of funny because it's not it's a quartic function. We have to really graph those.
Okay, so here's what I plotted. It looks kind of weird, but you have to remember when you're taking the inverse, the shape of it is pretty much the same. Okay, pretty much the same. You have to flip it over. So when I talk about my symmetric line here in yellow, y equals x, I know that this arrow is going to come down here. This arrow is going to flip here. So I know that this is going to go something along the lines of another W, but to the side. Oop, I totally missed that point. Got a W off to the side. Looks weird. Okay, I have that W off to the side. And it makes sense. Remember, I always say, do I understand what's going on? Look, here's my arrow, here's my symmetric line. I pull it and boom, there it is. It makes sense. If I were to fold this, they should meet. Okay, so try to make sure that you're truly understanding what's going on. So, let's actually kind of recap what we just said. Do you need another minute? Are you good? Looks like some of you are still drawing, so I want to give you a second. So remember, the horizontal line test is what tells us if the inverse is a function or if it's not. So something to kind of see here, if you want to use your highlighter, you can put that horizontal line test. Here it is a function because it only crossed once. Here it is not a function because it crossed 2 times, or intersected 2 times. And that's going to help us establish if we're working with a function or not for our inverse. Okay? So, pretty easy ones here for A, B, and C of number 6 here. Let's test it out. Use the horizontal line test to determine if the inverse is a function. So I'm just going to use my highlighter. I'm going to draw a horizontal line. Did that horizontal line intersect only one time?
No.
No, here, here, and here. So is the inverse a function?
Yes.
No, it only can cross one time for the inverse to be a function. So the inverse is not a function.
In that one, would the original function have been, or the original graph have been a function?
Yeah.
It does pass the vertical line test. It doesn't pass the horizontal line test.
Okay.
But
Yes.
right here it crosses the 2 points from the old one.
So like,
So this is not a function. You're right. But we didn't ask that question if it was a function or not.
you can
We
draw
just kind of
any
we just grabbed it.
horizontal line,
Oh.
any
Yeah.
all the way up and down.
You're right though.
Should probably cross it.
Okay.
The inverse is not a function, but this actual graph would be. So the question was asking is the inverse a function?
Good question. Okay, so let's try it again. I'm going to draw one horizontal line here. How many times did my horizontal line intersect my original function? 1. So is the inverse a function? Yes.
Okay,
inverse.
the question back there was like, how do you know where to draw your horizontal line? It has to be any horizontal line. So like if Miss Sable had drawn the horizontal line up here, it would look like that would have passed. But it has to work for anywhere on the graph if you drew the horizontal line. Okay, so that was a good question.
Okay. So another one. Try to do C on your own to see if you can figure out if that inverse is a function or not. Yeah. Okay, it's pretty straightforward. The inverse is not a function because it crosses 2 times. Flip the page when you're ready so we know we can move on. Don't have much left. Here's where this is going to be applicable. Okay? It takes a little bit to understand the domain and range in terms of the inverse and in terms of the original function. So graph the inverse of each function. So that's our first step. Let's graph them out. Is the inverse a function? Restrict the domain of the original function so the inverse is a function. So we want to make this function, the inverse, a function if it's not. And I'll explain that more in a second here. So let's first do the first step. It says graph the inverse of the function. So let's graph it. I'm going to pick some points. Here they are. Kind of already graphed them for you. Again, some of you might be able to just do that without listing them out, but we're going to write them all out just for the sake of the notes. I have -1, 0, I have 0, -1, and I have 1, 0. Someone's music is too loud, I can hear it.
Your music on anyways.
Okay, now let's chat. What happens to all of the x's and all of the y's? They flip, so let's go ahead and graph those out. So if I'm going to flip -1, 0, what does it become? 0, -1, so 0, -1, right here in green. If I flip 0, -1, what does that one become? Yep, right here in green. If I have 1, 0, which one does that become for the inverse? 0, 1, very good. Now again, some of you might be like, how do I draw this? Well, you can either graph more points if you really get confused, or you can kind of just visualize what I said. Where are the arrows going to go? This one should be going this way. This one should be going this way. You can see that if you understand it's symmetric about that line. Okay, so I'm going to go ahead and just graph it out. Now, the second question asks, is the inverse a function? When you're looking to see if the inverse is a function, I have to look at my original here. Does it pass the horizontal line test? No, because it crosses more than one time. In order to pass the horizontal line test, it only can cross one time. So is the inverse a function? I saw a lot of nods. No, yes, it is not a function.
Interior heads. Yeah, not a function.
Now I'm just going to put inverse so you know what I'm talking about.
Would the original have been a function? Yes.
Yeah.
But the inverse is not.
And we know quadratics are functions. We've worked with them a lot.
Can you show her where it crosses it twice again?
Yes. So here's my horizontal line here in green, and it crosses 1 and 2 times. Oh, okay, that makes
Good
sense.
question.
This is my symmetric line.
No, I'm not like, you know how we flipped it?
Got it.
And then this one.
Got
You
it.
always go back to the original when you're testing horizontal or vertical.
And if you want to label that first so you don't get confused, you can do that too. Now, it asks, what is the domain of the original? What is the domain of all quadratics? All real numbers. And I'm going to put that in purple so we can see the different graphs. Okay, that's my original. The green is going to be my inverse. Now, this is where it gets tricky. This is probably one of the harder of the bunch. This is the hardest one of the bunch. Okay, the question asks, if it is not a function, which we said it was not, can we restrict the domain so that it is? We can. So let's kind of talk about this. when we have our original function, remember what I talked about yesterday, the domain and the ranges always switch, correct? What's the range of this graph? Of our original? -1 to where? So remember what I said yesterday, the domain and the ranges of inverses and the original functions always switch. So what's the domain of our inverse? I heard it. It is -1 to infinity, and I will explain that. I will explain it, don't worry. Let me go over that one more time. Yesterday I explained that the domain and the range always switch when you have an inverse function and you have an original function. Well, if I'm asking for the domain, you're really looking for the range of your original. The range of my original function starts at -1 and I go up forever to positive. So I know that's going to be the domain. Also, we can look at it as when we have a quadratic function, what's the inverse of squaring something? I'm just kind of going off this aside here to kind of make sure that you understand. If I had a quadratic like that, you would square root it. So the inverse of this guy is a square root. You're right. What can't I have under the radical? A negative. Very, very good. Okay, and that's why we have to restrict the domain, because you can't have negative numbers. And if you notice here at that -1, that's when it's going to start being negative in our problem. Okay, these next ones are pretty easy. They're pretty straightforward. Let's look at this first one. A lot of you, I don't want to draw it out first because a lot of you got confused when I did that. But let's ask, is the inverse of this original problem going to be a function? Yes, because it passes the horizontal line test. Yes is function. Now let's graph it, because then it's easier for us to see without having another graph there. So I have some points, but make sure you be careful because a lot of them are the same because it's a cubic, right? So a cubic function, let's go and do something like, I don't know, -1/2 and 3. So I have -1/2 and 3. So what must the inverse then be? What must the inverse point be of -1/2 and 3? 3/1/2. So 3, -1, 1 1/2, right? Sorry. 3 and -1 1/2. They're in purple. We know that 0, 0 is going to stay the same. Let's pick another point from our original function. So our original function, let's pick something like 1 1/2 and -3. So 1 1/2 and -3. What now is my inverse point? Yeah, -3 1/2. So -3 1 1/2 here in purple. Okay. So we're going to go ahead and graph that out. Now, I just like to keep doing this so that you understand what's happening. You don't have to keep writing all of this out, but I'm just going to show you. This arrow, when I flip it over, is going to be going that direction. This arrow, when I flip it, is going to be going that direction, just so that you kind of have a picture in your head. Something like that. Okay?
If you can't see it, just pick some more points.
Yeah.
I mean, you can put 10 points on your graph if you want, so you understand what the picture looks like.
Okay, I want you to go ahead and try 7C because it's linear, so it should be pretty straightforward, the linear part. Oh, wait, hold on, I'm not done. What is the domain of all cubic functions? Because that's what the original is. Good. -infinity to positive. And the inverse is a function, and it's going forever left and forever right, so what's the domain of the inverse? Yeah, -infinity, positive. Or all real numbers, whichever one. Okay, try the next one, and we'll do the last one together. Oh, I got 2 more left. It's some pretty challenging stuff, but you got it. Got 3 of us now. Lots of help getting happening right now. and get as many points as you need. If you need 5 points, you need 5 points. For a linear, though, you should really only need 2, because you can draw a straight line.
Pick some points on that line, let them draw the next.
I know, right? Hopefully you got something that looks like mine.
If you didn't, call one of us over so we can help you.
And then so when you flip it, it becomes 3 zeros, right? Okay, now let's talk about it. Actually, I'll give you another second. Some people are still writing and asking questions.
I just didn't know because it just stopped. Yeah. So they already restricted it for you.
So my original is in purple. What is the domain of my original problem? All real numbers. What is the domain? All real numbers. And I forgot to do one of my questions. Is the inverse, this green line, based off our original in purple, is the inverse going to be a function? Does it pass the horizontal line test? Yes, so it is a function.
So as soon as you say yes, it's a function, you really don't have to worry about restricting the domain at all. Okay, it was just that first one that caused us
It's a
issues.
negative 1 and 2.
Yes.
Only the ones where the inverse is not a function.
So
That's
when it's a
what
function,
possibly
you
have
see
to
all real
restrict
numbers.
it.
Exactly. Okay. If the inverse is a function, is a really good question. It's going to be, yes, all real numbers. For the most part, until this next problem comes up.
It doesn't have to be.
All right, here we go. Let's talk about this one first. And I want to do the horizontal line test first. Here's my horizontal line. Is the inverse going to be a function? Yes, because it passes it. It only crosses one time. So the inverse is a function. Now let's go ahead and plot some points.
1 and 1, 4, 2.
Yeah, it's good. So we have 1, 1 for original, and we have 4, 2. So let's start switching them up. I know I'm going to be starting at 0, 0, because 0, 0, when you switch them, they become 0, 0. Well, 1, 1, again, when you switch them, it still becomes 1, 1. What happens to 4, 2 when you take the inverse of it? 2, 4. Whoa. Okay. We have not learned about radical functions yet. We will, but this is a radical. Remember what a radical is? It's a square root, cube root, blah, blah, blah. What's the inverse? And we talked about it a little bit earlier. If I had a square root of x, if I had something that looked like this, how would I, what's
X
the,
squared.
yeah, the inverse would then be x squared. You'd be squaring it. Okay, that's why it's an exponential. It's why, not exponential. It's why it's going up like that.
That's why that part in pink only looks like half of the U, half of the parabola. Okay, they already restricted the domain for you, but that's like,
So let's talk about the domain of the original function. The domain of the original function here in green. Going left to right. Where do I start? 0, and I go where? To positive infinity. Now here's a question. Is 0 included?
Yes.
Yeah, okay. So we have to have that bracket. It didn't have a hole like we did in the past, right? It's there. Now what is the domain then of the inverse? 0 to infinity, because it is a function. We didn't have, it's already been restricted. Okay. You're going to get your homework. The key is on the board already.
guys.
What I did not mention yesterday is that your cognitive tutor is up and running. You will have some time to do it, but it is ready to go. If you were not in this class before, we will get you set up and we'll let you know when you're ready to go.